So, good morning. We were discussing about the history of transmission insulators which are used for outdoor applications. As mentioned, we have three main types of insulators which are used for overhead transmission. The first being the ceramic or porcelain, the other is the glass, and third is the non ceramic or composite or polymer insulators which are being used widely for the transmission. So, we will look into the various manufacturing process of all the three types of insulators. So, this is how the story happens for the ceramic insulators or a porcelain insulators. Way back in 1880s, the insulator technology was initially being used for the telegraphic communication application, used for telegraphic lines. So, these insulators which were developed somewhere around 1880s, which are known as pin type of insulators, basically used for telegraphic conductor isolation there. Later on these were tried for the electrical insulation. It so happened up to a certain voltage the problems does not exist. Later on when the voltage levels increased, there used to be a flashover on the surface, and this is how the insulator technology has been come. And so, this is how various types of insulators, you can see several pin type of insulators since inception. So, various models, various creepage lengths, various types were developed across by various manufacturers, and they were being used for several decades. So, these are again an improvement aspect for the porcelain or the ceramic insulator. As mentioned, these are the two important these are the important people who have contributed to the development of a ceramic or a porcelain insulators, Edward Hewlett and Harold Buck. These two engineers who were working in Niagara Falls and the General Electric contributed to the recent designs of porcelain or ceramic insulators. Further several designs based on the creepage, based on the usage, like the insulator when they are being used for the desert conditions without many sheds, which are known as aerofoil, normal conditions, and also fog and anti-fog type. These were developed to cater the needs for the conditions where the contamination is more severe. So, various types of insulators have been developed over the period. So, these are of a recent origin or recent being used for the extra high voltage and ultra high voltage regions. So, you can see ceramic insulators basic or a glass insulator. Again, the glass is popularly used in Europe because of the material availability. Mechanically and electrical performance of ceramic and glass insulators being the same. So, we will be looking into briefly about the manufacturing process in due course. So, these are again various types of ceramic insulators which are used for railway traction, bushings, for the equipments, and several so on and so forth. So, this is the recent polymeric insulator. So, we will be trying to cover the ceramic, porcelain or a porcelain and glass and recent polymer or a silicon rubber insulators in detail in the coming lectures. So, how the porcelain insulator looks when you typically see the insulator cut section. The porcelain insulator or a ceramic insulator is made up of a cap which is known as made by the malleable or a ductile iron material. So, this is the cap of the insulator. You have a shell, this is a porcelain or ceramic shell which has different petticoats. As mentioned, these petticoats are used depending upon the conditions. So, this will the creepage distance what we call will be from this junction, that is a cement. We have again a sandwich between the ceramic is a metal pin here. So, this metal pin is of malleable or a forged iron material. So, you have a metal cap and a metal pin, in between you have a ceramic shell. So, this ceramic shell is being integrated with the help of the cement, that is a Portland cement. The Portland cement helps in having the contact between the cap and the pin. You can see a portion of the Portland cement on the cap, which will be mechanically coupling with the ceramic shell. Again here the pin gets coupled with the Portland cement here. So, basically cap, a ceramic shell and a malleable or iron pin. So, these are the important components. You have in between, to fix properly mechanically, you have a sand, that is Portland cement with the help of a sand band for a mechanical grip. Then you also have a bituminous coating here on this to see that the corrosion is not there. Similarly, here near the pin junction, the zinc sleeve is sometimes being adopted to see the corrosion does not occur, and because of the cement junction here, this could see cement growth and further the pin and ceramic shell getting detached. So, these are the basically important information about the ceramic insulator. This is a cap, this is a pin, and this is the shell of the insulator, or the creepage from the pin to the cap end. From here near the cement junction, cement is not usually connected with the creepage. So, immediately after the cement junction, the entire length from here forms the creepage up to this junction. So, this inside junction from the cement portion here to the end portion here forms the protective creepage, what we call, and this up to this is the total creepage. So, this is how the creepage length of a ceramic or a glass insulator is defined. So, we have known that the transmission, power transmission occurs from the generating station. So, transmission is very important component. So, generation as mentioned earlier, it could be of a thermal, a nuclear, or hydroelectric or renewables. So, from the generating stations to the load centers, as again I repeat, the load centers could be industrial loads, agricultural loads, it could be domestic, or it could be several for traction, so on and so forth. So, to reach the required customers or the required load, we use the high transmission, and this high voltage transmission consists of, as mentioned, the tower, the conductors, the foundation for the towers, various types of accessories which are used, insulators, so on and so forth. So, as mentioned, the power transmission from the generating stations to the load centers, load places is essentially through overhead lines. When I am mentioning the string insulators, again these are all the insulators. String insulators could be of a ceramic or a porcelain, glass, or a recent type of polymer insulators. So, these insulators usually perform two important functions. You can see that mechanical support to the tower. So, these either in the tension mode or in the suspension mode, you have to have a mechanical connection, that is a mechanical support to the tower. The second being electrically isolating the tower to the conductor. So, these are the conductors. Here for an example, you can see 4 bundle conductor with several accessories like spacer, corona control ring, and several of these. So, these conductors which are at very high voltages, so could be at 400 kV or 765 kV or 800 kV levels. So, these have this potential which are at the transmission voltages have to be isolated from the metal tower. So, for isolation you use an insulator. So, basically the number of insulators again depends upon the voltage level that we will be discussing in the future lectures. So, this performance of a string insulator or the insulator mainly depends, or it supports two important causes. One is the mechanical to the tower, and other is to electrically isolate this conductor from the tower so that the flashover should not occur. So, these insulators as mentioned are in the environment outdoor. So, most of the transmission lines you see they are outdoor towers which these insulators are being subjecting to various conditions like sometimes over voltage conditions. These over voltages could be because of the lightning, natural lightning which occur during the raining conditions or monsoon conditions where the over voltages should not cause the damage to the power equipment at the substations or at the nearby distribution stations. So, these have to be protected. So, these insulators also have to be are also been subjected to the ambient conditions. These ambient conditions could be environmental conditions like long term performance have to be done, this have to be performed in the field like environmental, it could be UV, ultraviolet radiations, it could be the dust which is going to settle, it could be the contamination, it could be the rain, it could be the fog, it could be the ice loading on these insulators. So, several of these conditions are being prevailing on these insulators. So, these insulators have to withstand all these stresses which are in the field apart from the electrical stresses, and these transmission towers or transmission lines depending upon the voltage level and also the generating stations to the load centers, the transmission lines run over a few hundreds sometimes to few thousands of kilometers in case of HVDC. In case of HVAC run few hundreds of kilometers. So, HVDC few thousands of kilometers. So, why I am mentioning this point is you have several towers, you have insulators all over the line length. So, these are subjected in case there is a failure at any point in the system, that is from the generating to the transmission to the distribution stations. So, the entire system could be brought down. So, this is so important, the insulation has to be maintained, the insulator should perform for all the conditions which are mentioned. So, how this insulator functions? So, we have mentioned the important mechanical and electrical importance as mentioned. So, the insulators, again here I would like to stress, it could be glass, it could be a polymer, it could be a porcelain. These are essentially used to maintain the distances, particularly the air gap what we call between the line conductors, that is the high voltage conductors, to the ground. It could be to the ground or it could put to the ground conductors. So, here it has to see that the safety margin is maintained and also the system voltages depending upon the voltage level, these clearances or the gap distance levels which are defined by the standards have to be always maintained. Apart from the environmental condition, it could be which are trees nearby or any other metallic objects which are nearby, to be seen that the clearances are to be maintained. So, proper safety margin as per the standards have to be done, are to be maintained, and contamination, as I mentioned, contamination or pollution conditions. So, this contamination is a very serious threat in particularly for this outdoor insulation. So, we will be discussing in more detail about the contamination or pollution effects on these insulators, how the performance is disturbed at the normal working voltages, which is a very serious matter. So, the performance of these insulators or integrity of these insulators will be designed based on the contamination or a pollution aspect. We will be looking into that aspects. So, further they have to withstand the mechanical stresses. The mechanical stresses, it is not only the supporting to the tower. So, these could be because of the dynamic variation, there could be a static loads or tension loads, because when the insulators are in tension mode, again insulators could be of double tension or a quadruple tension or 6 bundle tension loads depending upon the voltages 200, 400 kV or 765 kV levels. So, because of this dynamic changes, both compression and tension forces are exerted on the transmission conductors, and these insulators which support have to be able to withstand these mechanical stresses. So, mechanical stresses, as mentioned, again electrical stresses. These electrical stresses apart from mechanical stresses have to be withstood by the insulators. Here What are the electrical stresses? Electrical stresses would be the normal system voltages or the fields because of the voltage levels and over voltages. So, what are over voltages? So, over voltages again it could be because of the lightning effect, where the lightning strike the tower, a proper shielding or a ground wire is protected. In case that is not able to protect it, the entire, in case of the lightning strikes, so over voltages because of lightning could be induced, and these travel to the substations and the equipment in the substation could be damaged, or the insulator string could flash over because of this lightning effect. Apart from lightning, we have the voltages which are developed because of the switching effects. So, switching of the circuit breakers, closing or opening of the circuit breakers. So, switching surges are also developed. Apart from lightning over voltages, switching over voltages, normal working power frequency over voltages also do happen because of the some of the conditions where the line gets disturbed. So, it could be because of the normal conditions, that is the power frequency over voltages, switching, lightning, and the over voltage and performance to various environmental stresses. So, here again there are typical waveforms or typical conditions in case of lightning happens. So, the typical waveforms being 1.2 microsecond by 50 microsecond, 0.2 by 50, what we call the front time and the tail times of the lightning waves have to be impinged on these insulators and try to see that whether they can withstand for the lightning effects. Similarly, for switching, there is a waveforms which are defined in the laboratory experimentation, 250 by 2500 microseconds, the front being 250 and the tail being 2500 microseconds. These again we will be discussing during the high voltage testing aspects for the insulator string. So, apart from this over voltages, lightning, switching, normal power frequency over voltages, the insulator strings or insulator has to withstand the environmental stresses. Again, these environmental stresses mentioned could be due to the temperature of the area where this transmission towers are erected. It could be because of the cold climatic conditions, again in case of higher altitudes and the cold countries where the temperature goes much before below the sub-zero range. So, the ice formation or the contamination which is happening on the insulators sees that it conducts and there could be a flashover. So, this have to withstand to environmental stresses, not only to the very high temperatures, the cold conditions, ultraviolet radiations which are coming from the sun continuously, these are exposed for continuous day. So, this during the daytime, and contamination. So, contamination or a pollution is whatever was mentioned is a serious threat to the insulation of any kind. It could be polymer or glass or a ceramic type of insulator. So, contamination again we will be looking into the phenomena of the contamination, how it happens, what is the physics behind this, how the flashover could happen and how some of the design aspects are being considered for the extra high voltage and ultra high voltage transmission, why the contamination or a pollution plays an important role in the insulator functioning. So, this we will be also looking into that. So, before going into the details of further details of the insulation, there are important factors which determine the insulation design. So, when we look into the IEEE technical report which is available, this report clearly demonstrates voltage levels up to 4 kilovolts. So, 0 to 4 kilovolts, the factors which are mainly responsible for the insulation design are the mechanical clearances. So, the tower to the conductor clearances or the ground clearances. So, these are designed basically with the help with the clearances and other any equipment or any other material or a metal which is nearby to that. So, when the voltage levels above 4 to 33 kV, the corona and the lightning surges play a role in the design of insulation aspects. So, the corona again being the discharges which are happening near the vicinity of the high voltage conductor. Basically it is an air breakdown near the conductor or the metal or the aspect near the high voltage area. So, this breakdown near the vicinity of the conductor poses a threat, and the clearances are important in these aspects, and lightning surges. So, lightning, because of lightning effects, the insulation design has to be looked into, and the factors both are to be considered up to 33 kV or 34 kV. Similarly, when the voltage level is above 33 to 220 kilovolts, both apart from this corona lightning surges, switching surges take the importance here. So, switching surges, because of the opening and closing of the circuit breakers in the substations, these surges could cause or a flashover or could cause damage to the insulation aspects. So, proper protection or proper insulation design for the equipments as well as the protection system has to be done. So, up to 220 kV lightning and switching surges play a dominant role in the design of line insulation. Further to 220 kV level up to 765 kV, you can see that apart from switching, so lightning is also considered. Apart from lightning, switching surges play much more role in the line design, and you can see the contamination or a pollution. So, contamination pollution dominates above 400 kV and higher voltage levels, which we call EHV, extra high voltage or ultra high voltage range. So, where switching surges lightning surges, apart from lightning, switching and contamination flashover or a pollution flashover phenomena which dominates the scene, and this pollution or a contamination further to 800 kV, again the major portion or the major responsible factor for design of insulation is the contamination or pollution. So, the contamination or pollution as seen above extra high voltage levels takes an important role, and this responsible for this factor has to be considered for the proper insulation design at this voltage levels. So, you can see that for extra high voltage or ultra high voltage pollution is or contamination is a very important factor which is responsible for the insulation design. So, design engineers have to consider this. So, how serious is that, how it happens, why it is so important? The reason being this contamination or the pollution flashover occurs at the normal working voltages. So, this phenomena which occurs at normal working voltages, it is not due to the over voltages, has to be a very important design criteria which has to be looked, because several lines have been noticed and several lines have been seen that the tripping or the failure occurrence at the working voltages, particularly in during the monsoon or during the rainy seasons. So, the design is very important at EHV and UHV level for pollution. So, that is the basic information about the stresses to be which are encountered by the insulators, outdoor insulators, again various insulators in the field, and important aspects to be considered before the design for a certain voltage levels. Now, we will look into the manufacturing of various outdoor insulators which are used for high and very high voltages, extra high voltage and ultra high voltage ranges. So, as mentioned, again would like to repeat, we use porcelain or a ceramic insulators, glass, and recently developed composite or a polymeric insulators for outdoor applications up to EHV, and in the country we are also using for EHV and UHV the composite type of insulators. So, you can see this is the ceramic insulator as mentioned with the cap and the pin arrangement. Similarly, you can see the glass insulator, you have a cap and pin, again you have a glass shell instead of a porcelain or a ceramic shell. These are all the recent developed polymeric, composite silicon rubber. So, several names which are being used for the high voltage extra high voltage transmission, and also for the traction and other insulating for distribution levels. So, manufacturing of these outdoor insulators gives an idea. So, what could cause the issues, or what could lead to some of the processes, how importance is the manufacturing of each and every type. We will be briefly looking into this. So, first we will look into the manufacturing of the disc insulators, basically the ceramic or porcelain insulators which are more than a century old, and which have reasonably provided the performance up to EHV, and it is also being used for ultra high voltages, and these insulators have been originated over the century, and several types of insulators for normal conditions and contaminated conditions have been developed by various manufacturers across the globe and are being used for the transmission systems. So, we would like to see or focus on the disc insulators. Again, ceramic insulators, different types, it could be bushings, it could be long rod insulators. So, there are other types which are being manufactured. We will focus on the disc insulators which are basically used for transmission. So, disc insulators, there are several stages of manufacturing this porcelain or ceramic insulators. We look into the steps which are being followed. So, initially the processing of raw materials. So, what are the raw materials? Raw and auxiliary materials which are used for the manufacturing of these porcelain or ceramic insulators are basically clay. Clay is mud. So, this clay which is normally available in the country and abroad are being used for the porcelain manufacturing thing. Apart from clay, they use a kaolin. Kaolin is again a clay type of material. Along with the clay it is being used, or some portion of the quartz, gypsum, alumina, and some additives. These are the main ingredients or the raw material or auxiliary materials apart from the major clay, kaolin, feldspar, quartz, gypsum, alumina, and additives are used. The composition of these materials, so whatever the materials which are being mentioned, could differ to an extent. Particularly this has to be noted here during manufacturing, depending upon whether the insulator is for DC or AC applications. So, it is not that the same insulators which are being used for AC could be used for DC. Yes, to an extent it could be used, but during the manufacturing there is an extent which differs during the manufacturing process, in particularly for DC applications, where the alumina content for the DC varies from 20% in case of AC to 40% in case of DC insulator. So, this has to be noted. It is not the same material or the same mixture of the materials which have been mentioned. So, the alumina content, particularly in case of DC, variation could be seen. The raw materials which are mentioned are fed to the ball mill, which tries to mix up the material, where the ores of this material are properly grinded and crushed to a fine particles. So, here the ball milling, what we call in the initial stages, is done to see that the particle size is brought down somewhere to 10 to 12 microns. So, very small size the material is being crushed. After mixing, this slurry which is obtained, it contains again water plus the clay and other auxiliary materials. So, this is made in the form of a slurry, a fine liquid slurry, which is stored in large tanks which are fitted with mixture for continuous stirring. So, the continuous stirring is being seen in the initial stage. Further the filtering process happens. The slurry which is obtained by the raw materials is passed through the screen to move into a large size particles, making it uniform in shape and size. So, later the contents are passed through a magnetic separator. Why magnetic separator? It is basically to remove magnetic particles, mainly iron and so on. So, the scrap material which is obtained, that is which is removed, is again recycled for future use after the filtering process. So, further to the filtering process, dewatering is being done. So, this dewatering is basically after screening, the slurry which is obtained is pumped into the filter press, where mainly the intention is to remove the water, wherein 18% of the moisture is removed in this process during dewatering. So, the slurry, the paste which is being formed, the 18% of the moisture is removed in the dewatering stage. Further, the clay that emerges from the after the dewatering is passed through the filter press. Further, similar to the pancakes with a stiff mud is obtained. This stiff mud, which contains again about 15% water, this is loaded into what is known as a pug mill, where the mud is shredded by the knife blades under the vacuum conditions. So, this process of vacuum extrusion mainly removes the trapped air from the clay, which is would otherwise give rise to voids during the manufacturing. So, air bubbles or void should not be present during the manufacturing process. So, this process of vacuum extraction sees that these voids or air bubbles are removed. So, presence of any air pockets is not desired, as mentioned. It will disturb the homogeneity of the material which is being used when after the manufacturing. This could cause the failure in the field. So, further to the vacuum extrusion, this material goes for, or the material which has obtained goes for the shaping or forming cycle, what is known as. So, here again it has 3 sub divisions for inner shaping, drying and outer shaping. Inner shaping again consists for suspension or a pin type shells are basically done using the press mold type of arrangements, while clay remains in green color. So, this stage these molds which are used are sliced sections are dropped into the molds or die sets, what we call. These die sets or molds are basically made of plaster of Paris and pressed into the regular shape. So, this plaster of Paris molds are used as they absorb water, moisture and aid in rapid drying. So, the importance of using this plaster of Paris molding is to see that the drying should be faster and also the moisture should be removed. So, usually gun type metal type of die set is employed to provide proper shape to the mold. So, this is again for the inner shaping. Further it goes for the drying, where this pressed pieces of the inner shape are slowly air dried, and the plaster of Paris molds with pressed pieces are put inside the dryer chamber. So, which is known, see that the mold with the contents gets dried over a period of time. So, this drying process is continuous. It could be for 1 to 1.5 hours, and during this process of drying, the temperature is maintained anywhere around 45 degrees continuously. So, further the outer shaping. So, outer shaping of these samples are done at the other end of the dryer, and these are normally kept for 24 hours before final machining is done to the insulator samples. So, this undergoes shaping, inner shaping, the drying and the outer shaping in the formation of the insulator in samples. Further to this, insulator process, glazing has to be done. So, the glazing which is done on the surface of the insulator is mainly to see that during this process the insulators which are obtained are dipped into the slurry of glaze. So, glaze is again the color of the glaze depends upon the metal oxide and its composition. So, it could be brown for iron oxide, green for chromium oxide, etc. So, the glazing serves several purposes. The intention is to see that this glazing gives color to the devices or disc basically disc insulators for identification of different type of insulators, makes the surface very smooth, reduces the leakage current in case of using the high resistive glaze. It improves the mechanical performance of the insulator and this disc shrinks on glazing, and the glazing also helps in thermal expansion of glaze is lesser when compared to that of the ceramic portion. So, thus is also called as compressive glaze, which makes the insulator compact. So, very important. So, insulator has to act in compression and also the tension modes. So, a glazed insulator usually has two important parts, that is the ceramic part and the glaze which is coated outside. So, consists of two parts, which is inside is the ceramic, outside is the ceramic coated with the glaze. The sand which is bonded by glaze to the surface coming in contact with cement is to ensure proper grip. That is the sand which is used after below the cap and pin and cap have to be arranged to the ceramic cell. So, this ensures proper bonding between the metal and the ceramic shell. So, the final stage is the firing, very important stage in the manufacturing of ceramic disc insulators. Here the glazed samples which are obtained are sent into the kilns, hot kilns or very high temperature kilns for complete verification to maintain the strength of insulations. This firing zone usually consists of three zones. One is the preheating, the firing and the cooling zones. So, two types of kilns are usually employed for heating these insulators. So, provision also is made for gas tunnels, kilns where insulators are continuously heated for more than 24 hours up to 365 days. The second type of firing depends where insulators are sent inside an heating chamber in the wagons or the carts, where each wagon consisting of several insulators spends more than 60 minutes in a particular zone. So, several zones and comes out by the end of 72 hours. So, each 60 minutes, that is 1 hour to 72 hours. So, this process involves the firing, which is very important process of the manufacturing of insulator or a ceramic insulator. So, this gives the entire flow chart or the manufacturing process whatever we try to discuss. So, we can see the raw materials as mentioned, it could be quartz, feldspar, alumna, clays, several of these things are mixed using the ball milling, and this slurry is passed on to the further grinding to a fine particles. Then these grinded fine particles are sheaved to a certain using the blade type of arrangements, and the materials which are still available like iron and other particles are removed with the magnetic separators. Further, this materials in suspension are sent to dewatering, where the 18% of the water is removed, and the homogeneous mix and the drying or the airing of the samples are done. Further, the shaping using the molds as mentioned, using the plaster of Paris molds or die sets, the shaping is done. It could be a disc insulator, it could be a bushing or whatever we were discussing. Further, this goes for the drying for a certain period. Then as mentioned, the glazing of the insulators, again it could be the bushing or the disc insulator, where the glazing is properly done and sent for firing. So, firing as mentioned, there are two types of firing methods which have different zones where heating, cooling and firing zones each have to spend some certain time, and by the time it weeds out, also the defective insulator samples are removed by sorting. Then further to the obtained after the firing, the samples are being sent for the testing, that is what is known as the internal or a routine type of arrangement testings which are done in the factories. So, this testings mainly looks into the porosity, whether any particular voids are present in the samples during the manufacturing process, or whether they could withstand the hydraulic pressure, temperature cycle and electrical flashover tests. These tests are performed after the firing, and further the assembly of the insulator is done. Assembly in the sense the pin, the cap and the shell are connected with the help of a Portland cement and the sand which is on the to mechanically support. So, this assembly is done. Further after the assembly, the testings for the mechanical and electrical flashovers are carried out. So, this involves the factory testings for both mechanical and electrical. Again here the mechanical tests are depending upon the insulator strength. It could be for a typical creepage, a typical usage. So, the mechanical strength it could be 70 kilonewtons, 90, 120, 210, 420. So, depending upon the mechanical strength required, the insulators are manufactured. This have to undergo the mechanical strength and the electrical flashover. So, after this the dispatch of the insulators in the crates is done and it is sent to the utility centers. So, this is how the flow chart of the manufacturing process for a ceramic or a porcelain disc is carried out. So, we will further look into the service experience in the next class. So, thank you.